Okay, so the pilot of an airplane wants to fly due north, but there's a 65 kilometer per hour wind blowing from east to west, which means that it's pointing west. In which direction should the pilot head her plane if its speed relative to the air is 340 kilometers per hour? Give your answer in degrees north of east. So, the pilot wants to fly due north. Okay? Now, that's the resultant. Since that's the way we actually want to go, meaning that they want to fly the plane due north relative to the ground. So we'd say that's the speed, we could call it speed of the plane relative to the ground. And again, that's our resultant. Doesn't mean it's a hypotenuse, because this isn't a right triangle yet. Now they want to know in which direction should the pilot head her plane. Okay, so there is a wind that is going due west at 65 kilometers per hour. So this is the speed of the air relative to the ground, VAG. Then over here is another vector. That's the vector that we want to find, even though we kind of know what it is. So all they want to know is the direction of this vector. And that would be the speed of the plane relative to the air. Now we have what this value actually is. There's 65. So this is equal to 65 kilometers per hour. Since everything is kilometers per hour, we can keep it in that. This has a magnitude of 340 kilometers per hour. Okay, and we know that that is due north, correct? This is due north. So may have been a little bit more convenient, I guess, to draw it in the other, way. But just for simplicity, let's move these vectors around. Just flip this to drawing it like that, like this instead. So just drawing the same thing, but that's not right. Yeah, it is. All right. So again, and we want to know that angle, and we know this side is 65, and this side is 340. This is the same thing as that. I just drew it slightly differently. So since it is a right triangle, we can figure out any unknown sides if you wanted to. So this is 340. So if we wanted to, could we figure out the magnitude of this side? Yes. Right away, can we figure out what this angle is? Yeah, just using simple trig rules. The hard part is figuring out how to draw the triangle. And again, it doesn't, I just drew this because you can see that the angle's inside the triangle a little bit more. Drawing it this way, but again, both pictures are the exact same thing, even though it's because of my terrible drawing skills, the pictures don't look exactly the same. So if we want to know this angle, and we have a adjacent side and a hypotenuse, adjacent and a hypotenuse, so what trig function we want to use to find this angle? Cosine. So we can say cosine of theta is equal to adjacent over hypotenuse, or 60 over 340. 65 over 340. So that means that theta is going to be equal to inverse cosine of 65 divided by 340. Which should come out to be about 79 degrees north of east. One can say degrees north of east, and two, because we should see it. This is the, the direction that we're finding. We see that that's going north of east.